As you look at the title of this section, Making a Good Thing Better, Rapid Spanning Tree Protocol, I know that one or two of you out there may be thinking, so Chris, what have you been teaching us so far? Slow spanning tree protocol? And I assure you that is not the case. I've been teaching you regular spanning tree protocol, but STP is fantastic at what it does. And we need it to get done a little bit faster and maybe have our convergence done in a little more orderly fashion. And that's why the rapid spanning tree protocol was developed. Now, RSTP is defined by IEEE 802.1W, and it's considered an extension of good old-fashioned STP, which is 802.1D. Couldn't hurt you to know those two standard names by heart. So where does the rapid part begin to come in? Well, one of the places it comes in, or why we developed it, is that 30-second delay we have with the listening and learning states. Obviously they're important. I hammered you over the head with that in the last section. You want to don't change those timers unless you really need to. We need that 30-second delay to prevent switching loops. And one reason that 30-second delay was arrived at, these default values from Cisco, they may seem like they're pulled out of a hat or somewhere else on occasion, but they're default values for a reason. And these particular default values, they were once considered an acceptable delay. That was fine. And in many networks, they still are. STP runs in plenty of places. It's not like you got to go out tomorrow and rip STP out of your network. But RSTP makes things a bit more rapid, and as we'll see in an example later, convergence is a little bit more orderly. The overall concept of the root bridge, as with some other concepts, still present in RSTP, but the port roles are a little bit different. So we're going to look at the roles in this walkthrough where switch 1 is the root. And notice that switch 3 has multiple connections to the Ethernet segment. I grant you this is not a terribly real-world scenario you're going to bump into a lot, but this does allow me to illustrate the different RSTP port types. Now the root and the designated ports, they've already been selected. Switch 1's been elected the root, and just as before, the root bridge never has root ports. It's going to have those designated ports, and fast Ethernet 2 and 3 on switch 1 are the designated ports. Assuming that all links are the same speed, switch 2 has selected its more direct path to switch 1 as its root path, so fast Ethernet 2 is going to be the root port. Same goes for switch 3, except of course we're using fast Ethernet 3 on that particular switch as the root. Now we need a designated port on that shared segment connecting switches 2 and 3. And that should sound familiar because we had something very much like this in our STP example. And again, as would expect, the DP is going to be the port with the lowest root path cost of all the ports on that segment, and we're going to assume that to be one of the two ports switch 3 has connected to that segment for our walkthrough. So, so far not a whole lot of differences. But here they come. Because RSTP has what we call alternate ports rather than blocking ports or blocked ports. The alternate refers to the port simply having an alternate path to the root switch than the actual root port does. That's where the word alternate comes from. Now switch 2's port on the shared segment is an alternate port, ALT. But what of that remaining port on switch 3? Why did I put that there? Well, I wanted to illustrate to you what a backup port is. This port gives 3 a redundant path on that segment. It doesn't guarantee the root switch is still going to be accessible, but that's where the backup path comes in when there are 2 or more ports leading to a shared segment like this. One of them is going to be chosen as the designated port, and the others are going to be the backups. Now, there are slight and important differences between our port states as well. You want to watch this on the exam. They're not going to try to trick you, but if they're asking about STP port states, we can't give them RSTP port states. If they're asking about RSTP port states, we can't give them STP states. The STP ports disabled, blocking, and listening are combined into the RSTP state discarding, which is the initial RSTP port state. Now, RSTP ports transition from discarding to learning, and that's where incoming frames are discarded, but the MAC addresses are being what? Learned by that switch. And then finally, the RSTP port transitions to forwarding, which is the equivalent of STP's forwarding state. And just a quick comparison for you here before we talk about edge ports and point-to-point ports. STP ports go disabled, blocking, listening, learning, forwarding. RSTP, discarding, learning, forwarding. Those are the two paths. Now, the root port concept, we've got that one down cold, but RSTP brings with it two unique port types, edge ports and point-to-point ports. Now, a point-to-point port is really any port running in full duplex mode. And here we've got two switches connected, full duplex connection, and that is going to be a point-to-point port, as we'll see on the live equipment in this section. Now, any ports running half duplex are considered shared ports, as you would expect, because that's set up, half duplex is really set up for a shared topology, a shared network segment. And in that case, you got to run STP. You can't run RSTP there. Now, the edge port, this is such a simple little thing, but it does play a huge part in RSTP. An edge port is simply a port on the edge of the network. Yeah, I know. Duh. There's a little more to it than that. Likely, very likely, it's connected to a single host, such as an end-user PC. And to configure a port as an RSTP edge port, all we do is run spanning tree port fast. That's all you got to do. Just put that on the interface. Now, an RSTP edge port is a port fast enabled port. And what can that do? An RSTP edge port then can go straight from discarding to forwarding. Now, if a BPDU comes in on an RSTP edge port, it is demoted to a regular RSTP port, and it generates a topology change notification BPDU. We talked about TCNs a little bit earlier in the STP section, but more on that very soon. So you're thinking, okay, well, that's an edge port and that's fine, but what's the big deal? Well, here's the big deal. Edge ports play a huge part in RSTP's determination of when a topology change has actually taken place, because edge ports don't really make topology changes take place. RSTP considers a topology change to have taken place when a port moves into forwarding mode, unless that port is an edge port. RSTP does not consider that to be a change in the network. And you know what? That makes perfect sense. If a single host is connected to that port and it comes online and the port goes to forwarding mode, big deal. That's basically what switch 2 would say in this situation. Yawn, I don't care, a host is coming online. That's hardly an earth-shattering change to the network, so RSTP does not even bother alerting the rest of the network about it. There's no need to. However, when a non-edge port moves into forwarding mode, that's when RSTP does bother letting the rest of the network know. RSTP does that by sending BPDUs out all non-edge designated ports. And as we'd expect, the TC bit, the topology change bit, is set on those BPDUs. Now, switches that receive those BPDUs are going to remove all entries from their MAC tables except for the port the BPDU wrote in on. And as we would expect, those switches send BPDUs with the TC bit set out their non-edge DPs, and that continues until the entire network's been notified of the change. It's not an official term. I call it the ripple effect. It's really like just taking a pebble and dropping it into a pail of water or the ocean or whatever you have handy, and you just drop it in, and you see the one little wave come out, and then another little one, and then another one, and then another one, until it finally fades. Well, here, it's not going to fade until every switch in that network knows about this change. It's pretty cool, and it's a very orderly way of updating every switch in the network. Now, speaking of those BPDUs, another major difference between STP and RSTP is the way these are generated. We know with STP, the root bridge actually creates them, transmits them every 2 seconds. That's our hello time. And the non-root bridges, what do? They read them and relay them. That's a great way to remember it. They read them and relay them. But in RSTP, when you've got RSTP-enabled switches, they generate a BPDU every 2 seconds, regardless of whether they've actually gotten a BPDU from the root in that period of time. So every switch in your RSTP network is actually creating BPDUs. The hello time interval is the same in both STP and RSTP. Now, that little change in operation from STP to RSTP, that allows all switches to have a role in detecting link failures, and the discovery of those failures is faster. And we are always in favor of that, because the faster we find the problem, the faster we can get it fixed. Because In RSTP, every switch expects to see a BPDU from its neighbor every 2 seconds. And if 3 BPDUs are missed, the link is considered down. And that switch then will immediately, keyword immediately, age out all information that concerned the port that was receiving the BPDUs. Now, how does that cut the error detection from 20 seconds in STP to 6 seconds in RSTP? Because when a switch running STP misses a BPDU, what happens? The max age timer kicks in. And that timer dictates how long the switch is going to retain the contents of that last superior BPDU that it got before it finally ages out. And then we start the entire recalculation process with STP. Well, that's 20 seconds. Compare that to this process where the superior BPDU is aged out when 3 hello time intervals pass without it being refreshed. So that is one key change between STP and RSTP that does help us out and helps bring the more rapid part into Rapid Spanning Tree Protocol. In the very next video, we're going to talk about a little something called RSTP synchronization and have a walkthrough of that in action and some live commands as well. I'll see you on the next video.